Hi, everyone. I am Jim Berriman. So during the course of my litigation career, I have been a paralegal. I've been a litigation database software developer. I've been a litigation attorney. I've been an in-house litigation support manager. I've been an outside vendor. I taught the first e-discovery course at Boston University Law. And I founded Evidoc. So I've seen e-discovery and litigation technology from the point of view of what paralegal, developer, attorney, vendor, educator, support manager. And in all of those roles, and pulling all of that experience together, the one thing I've learned about litigation technology is that attorneys will not read the manual. Attorneys think conceptually. They don't want to know the technical nuts and bolts of the elements of e-discovery by and large. But that's a good thing, because what attorneys are best at is thinking conceptually and not getting lost in the weeds. And so if you've heard me speak at other events, you know I usually start with this slide, which is that issue spotting applies to the practice of e-discovery just as it does to any other element of the law. And what does this mean? It means basically that the attorney is not going to get lost in the minutiae. The attorney is going to conceptualize, going to abstract, going to look for patterns, and then use that to identify claims, defenses, to identify the issues with which the attorney will address to prevail in their case or get the best result possible. A lot of you have probably seen other presentations on e-discovery, and you've probably seen presentations on computer forensics, but you probably haven't seen one where the division between the two is addressed. It seems to be an area that, that no one has worked with much. So what I'm going to talk about today is, where is that dividing line, and how do we distinguish traditional active file e-discovery from computer forensics? The reason this is important is it's a threshold issue that you, the legal issue spotter, need to think about at the outset of the case, when you're preserving evidence, when you're gathering evidence, when you're figuring out how to learn what facts will support your claims or your defenses. So let's talk about active file e-discovery first. Active file e-discovery is what most of us think of as normal e-discovery. Basically, it involves active files, files that you can see on your computer. It involves user files, files that the user creates or accesses, as opposed to system files, system caches, and things that the user normally does not touch. And we can think of these as human-readable files. These are the files that a human being will be able to interpret when they look at them. They tend to be created by users, they tend to be accessed by users, and in the context of litigation, they are often in traditional business formats. This is your Word documents, your Excel spreadsheets, your PowerPoints, PDFs, emails, things like that. And depending on the context, it could also be multimedia files, advertisements, photographs and such. So that's active file e-discovery. So if we think not in terms of the technical format, let's put that aside. Think in terms of its business function. These are communications, correspondence, the reports and financials. These are the documents that the business uses to do what it does. Or just think of it as the electronic equivalent of traditional business records. Electronic business records is the subject of active file e-discovery. You can think of these also as the electronic equivalent of what would have been traditional paper files 10 or 20 years ago. Reports, invoices, letters, patents, leases, contracts, etc. And when you think of documents like that, the relevance or importance of such a document depends on what you see on its face, right? You look at the document, you assess its substantive content, and you decide whether or not it's important, whether or not it's material, right? So with active file e-discovery, what matters is what's on the face of the document. So face of the document, right? You're looking at a contract or a proposal. What are the terms? What are the warranties? What are the disclaimers? A specification, what is its scope, what is its definition? If it's a letter, a communication, an email, what does it say to the recipient? If it's an invention, what does the patent claim say? What are the words? If it's an advertisement, what is the seller representing to the buyer, right? All of these things are assessed based on the substantive content on the face of the document. And this implicates, of course, traditional legal issue spotting. That is what we, the legal professionals, already know how to do. You look at a document. Is it relevant? Is it important? Is it material? Is it privileged? We don't need any technical knowledge to make those assessments because we're just reading what's on the face of the document, right? So technical expertise is not required for determining what is relevant in the context of active file e-discovery. Now, let's switch to forensic e-discovery. Forensic e-discovery is an entirely different creature. It's looking behind the face of the document to look at the digital environment in which the document resides or in which the data resides. We are looking at the context of the file, not what's on the face of the file itself. And what this often implicates is conduct. What did the user do? What did the user do with the document? What did the user do with the computer? Putting aside the question of substantive facial content. So scope of forensic e-discovery. What are the kinds of things you think about? You think about spoliation. Has somebody deleted data? And if so, can you get it back? You think about authenticity. Did somebody mess with this document? Did they alter it? Did they change the document? Did they fabricate the document? History. When was the document created? Who touched it and when? Access. Who opened the document? Who looked at it? Transmittal. Did this document travel? Was the document transmitted as an email attachment? Was it copied to a USB device? Was it burned to a CD? And then user activity. What did the user do with that computer at a particular time? Right? So these things, we're not looking at the face of the document anymore. We're past that. We're looking behind it. We're looking at the digital environment to figure out what was done. So what are we looking for now? We're looking for the technical clues surrounding the evidence to let us know what might have happened. We're looking at the environment in which the evidence resides. Where do we look for these things? Unlike looking on the face of the document, we look at things like system caches, which is where the computer makes a working copy or a backup or a scratch copy of a file for its own purposes, and we can find that and look at it. We look at system databases, like the Windows registry. When you create a new user account, when you plug in a USB device, the system keeps track of these things and logs them and stores them in databases in the operating system. The file system data, that's like what was the date that a document was created or accessed. That stuff might not be apparent on the face of the document, but the system is keeping track of it. And then technical data within files. So for instance, if you look at email headers, you can sometimes see the travel history of a document, an email that came to you through your email system. And then you can look at the residue of past disk activity, deleted files, things like that. So in forensic e-discovery, not looking at the face of the document, looking at all of these technical clues in the environment where the documents lived. So now this is a different kind of issue spotting. This requires not legal issue spotting, it requires technical issue spotting. And this requires someone who has the technical expertise to make those assessments. Now, at the beginning I said, attorneys do not want to read the manual. I understand that. Attorneys will, however, look at a one-page checklist. So I know you guys, you'll say you like your little practice aids. So I have put together what's going to be on one page, just about everything you need to know about the division between active file, traditional e-discovery, and forensic e-discovery. So let's start at the top left there on the active file side. Where does the evidence live? Where's the evidence? It's in the active user documents in active file e-discovery. It's on the face of the document, substantive content. What is the focus? It is the substantive content on the face of the document. What is the objective of active file e-discovery? It's to find the relevant documents. What kind of expertise does this require? Us, legal issue spotting. We make the assessment of whether the document is relevant, whether it's privileged, whether it's important. And who does that? We do. This is the province of the legal issue spotter. And what is the result of this process? Typically, it's a document production. We winnow the documents, we separate wheat from chaff, we find which ones are important, and that becomes your production set, or that becomes your exhibit set for whatever you're doing, your investigation or your litigation. Now let's switch over to the forensic e-discovery side. The evidence resides in the digital environment, not just on the face of the document, but in the entire digital storage area where the documents and data live. What is the focus? User conduct. things that happened on that computer, things that happened with those files behind the face of the documents. What is the objective? Find technical clues to tell us what these things were. What kind of expertise is that? Technical issue spotting. Who does it? The forensic expert. And what is the result? It's an expert opinion or report. So now, with this, if you take nothing else away from this presentation, remember this sheet. We are going to make this PowerPoint available for download on the eDiscovery site afterwards. But this is basically the core of the difference between active file and forensic eDiscovery. And the bottom line is that forensic eDiscovery is an expert-driven process that results in an expert assessment, opinion, or report, as opposed to active file eDiscovery, which is simply the winnowing of electronic business records with the attorney's issue spotting mind to create a production set. So with all of that, let's talk about the general methodology so that at the beginning of the case, you have an idea of what processes apply to what set and how to use them. The general methodology of active file eDiscovery, we've all been here before, right? There are certain repositories on the mail server, the file servers, the local workstations. We identify them primarily based on custodial identification. You know, the particular email accounts, particular folders on the file server, particular files on the workstation, etc. And what we do is we identify the relevant custodians, because electronic documents tend to be stored according to custodial accounts. We identify the relevant repositories, such as the mailboxes, the folders, the databases. We preserve those repositories. We then talk to the custodians if we can, if they still work for the client, to figure out within those repositories what we're looking for. Then we select the sub-repositories of interest, the particular files and date ranges that matter. We develop the culling and processing criteria, the keywords, et cetera. Disclose to the other side what we're doing, create the review set based on all these criteria. We, the attorneys, review the documents, determine which are responsive or not, and we end up with a responsive subset that we produce. And if we want to look at this very quickly in a visual way, there's the entire universe of the client's documents. There's the subset that we preserve because we think they're potentially responsive. There's the subset within that we select because we think they are likely to contain the most responsive documents. That's the mailboxes of your key custodians and folders and such. We process it, winnow it, filter by dates and keywords and file types and such, and we end up with that review set, which we take out. We review it, we, the attorneys, make the designations, figure out what is responsive, and then produce that to the other side. That normally takes me 45 minutes to teach the law students. But you can see what happens, right? We start with a big universe, we go down, 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 and at every step, we, the attorneys, are pretty much driving this bus, saying, these are the criteria by which we get to the next step, this is what we want to look at, this is what we produce, and out it goes. Now, forensic eDiscovery, pretty radically different. And I'm going to focus on Windows systems just because that's what we encounter most often in the business environment. In Mac world and Linux world, there are similar analogous things, but I'm going to go Windows for now. And this, I apologize, I told you I wasn't going to go into the weeds, I wasn't going to go into the nuts and bolts, but I will. I'm going to two terms that I'm going to get technical on, byte and cluster. A byte is just a single character. It can be a letter or a number or a symbol. It can be a code like a tab or a return. It could be a unit of data like a color specification in a graphic file or something. It's the smallest unit of data we care about. It's one character. Think of it that way. What is a cluster? We're going to talk about school buses. Imagine that you are the chaperone of an elementary school class that is going to go to the Massachusetts, or the Museum of Fine Arts for a field trip. And you have 50 students. You could call up 50 different cabs, each of which has a different number, and put one student in each cab and send them off to the museum, and then someone else could keep track of all those 50 cabs to make sure they all arrive. And that would work, right? It's absolutely feasible to do it that way, but it's logistically complicated. Instead, you could call one school bus that has one number, put all 50 students on that one school bus, and it goes to the Museum of Fine Arts, and then one person says, yep, it's here they are, right? That's the difference between a byte and a cluster. A cluster is a handy organization of a set of bytes to let you handle them as a unit. This has pluses and minuses. The pluses are that it makes it very easy to keep track of larger amounts of data without keeping track of every character and its own separate address on your hard drive or digital storage space. The downside is that it's less efficient because not every school bus is full, right? If you have 3 students, then you've got a school bus with mostly empty seats, and that extra space is wasted. But in the computer world, we take that trade-off because it makes it feasible. So basically, in the Windows world, most clusters are about 4,000 characters, 4,096, because it's a power of 2 in a binary world. And those are the units allocated for storage space to avoid the problem of having to keep track of every individual character as its own individually stored bit of data. Okay, so I'm not going to go too deep here, but imagine that this piece of graph paper, which has 3,200 cells, imagine that this represents an unformatted hard drive or a memory stick. So it's got 3,200 slots available to hold characters. It can hold 3,200 characters. At this point, there's no clusters, there's no files, it's just unformatted space. When we format it, what happens is the file system of whatever your operating system is, in this case Windows, divides it up into clusters. Now there are far fewer clusters. In this example, there are 50. Instead of having 3,200 addresses to take care of, there's only 50, but each one contains 64 bytes apiece. So that's sort of, these are our school buses. Think of these as each a school bus. Now imagine that you sit down at your computer and you open up a text file and you type, what do we have, 54 characters, and you save that, a very small file. You see that it occupies most of one cluster, but there's some empty space at the end. That is one cluster, one file. The logical size of that file, which is the actual characters you typed, the dark blue, 54 bytes. The physical size is 64 because the entire cluster has been allocated to that, because that's our school bus. And the leftover space in that school bus, the unseated seats, is 10 additional characters, 10 bytes. And all the other clusters, the other 49, are all unallocated. They're not assigned to any file. So that's how the file system is basically keeping track. So now imagine that you, the user, after you've typed your little memo with 54 characters, want to make it a little bigger. You open it again, you type a few more characters, and now what's happened is it's overflowed into the next cluster. The file system gives you one more. Now you're up to 100 bytes, 2 clusters. Your slack space, the empties, is, 28 bytes. And now you have 48 empty ones, right? And you can keep doing this. And each time you go, this was just to indicate that even one character gives you one more cluster. It rolls over to the next, and that's allocated to your file. So now 4 clusters allocated to that file. You're still with me, right? Haven't gone too far. Okay, so what happens when you format a drive? Well, the drive originally has, think of it, it has bytes but not clusters. It has enough storage space to hold the number of bytes that it can handle, but they are not organized into clusters. So when you format it, the clustering is done, which is simply the file system keeping track of what size the units are. And one other thing happens, which is very interesting, is the file system creates the first file. And the first file is called the master file table. And the master file table is itself a file, and it's the file that keeps track of all the other files. It's the table of contents for the drive. And what's interesting about the master file table is that it keeps track of itself. This is kind of an interesting thing. The first file, because the first file is a file, and because the master file table keeps track of files, the first file listed in the master file table is itself, and it points to itself. Just sort of a interesting, iterative, logical decision that I believe Bill Gates actually invented this, the original file system for DOS. So anyway, so the master file table, think of it as the table of contents. It's going to point to every other file on the drive. This is also the source of what we think of as file system metadata. Metadata being data about a file that does not necessarily appear on its face. So let's say this document, let's say this is a PowerPoint hard copy printout. It shows all my slides, but nowhere in this file does it actually say what the file is named, or that it has a .ppt extension, or what the original create date or access date or modified date is. the file has those attributes, but they're not here. They're in the file system, and they're what you see when you look at Windows Explorer. So, for instance, you've all seen this before. You open up Windows Explorer, and you see a listing of the file name and the path and the file extension, and you see the file size and the create date and everything. All of that data is coming out of the master file table, which is the thing keeping track of that. And when you call up Windows Explorer, it just gives you a view of some of that data. So it's also the source when you right-click on a document and look at its properties, and you see like the difference between the file size and the size on disk. That's the difference between clusters and actual bytes being used. So this is all, again, coming out of the master file table. So with all that, that's all the background I'm going to give you on the technology. And now we're going to go into the disgruntled employee scenario. All right, I told you at the beginning that active file e-discovery, you look at the face of the documents. Forensic e-discovery is usually conduct-based. The scenario that comes up more than any other is the disgruntled employee who steals data and puts it on a memory key the day they quit and they walk out the door with it. We get this scenario over and over. And so you think to yourself, from an issue spotting point of view, the disgruntled employee who leaves and goes to a competitor, do I care about what's on the face of the documents, or do I care about conduct? Well, kind of both, because you care about what documents the person takes with them, because that might be your customer list or your proprietary formula for your product, so that matters. But you also care about what that person did. You know, did they put a memory key in their computer? Did they copy files down? Did they forward files to their personal Yahoo or Gmail account? Did they burn a CD and walk out the door with it? So that's the division. That's active file e-discovery, we care what's in the documents. Forensic e-discovery, we care what the person did. So here's our disgruntled employee scenario. Let's say that they have a memory key that's been formatted. So here it is unformatted, just to take us through the steps. We format it. It's all unallocated space because there's no files on it. And the master file table is created and occupies the first set of slots in our available storage space. This is just a schematic, right? And if you look in the master file table, it lists itself as the first file. That's the gray line at the top. So now our employee has this memory key. It's formatted, it has a master file table. And let's say the disgruntled employee is going to draft a cover letter to their new employer, using your computer, of course. And so opens up, and that's in blue, right? It's listed in the master file table. It has metadata. It's got the path, the date stamps, and everything. It's got a file name, and it occupies space in your storage area. So that's blue. So the employee is drafting that, and it's not done yet, so they stop, but they do something else, and they copy down a sales meeting PowerPoint. Let's say they copy it off the network, and they copy it onto this memory stick. So now you have two files. One's blue, which is the cover letter. One's yellow, which is the PowerPoint. Now, they copy down the customer list, which is an Excel spreadsheet. So the Excel spreadsheet now occupies a bunch of space on our memory stick. Now, they work on their cover letter some more. And you see what happened there? They're working on the cover letter, and they worked on it so much and added so many more characters that it filled up that last cluster. And since the next one was already taken by the sales meeting PowerPoint in yellow, it had to take the next available cluster, which is a bit further away. And that's what we call a fragmented file, right? Now the file is in two places. The file system is fine with that. It can, when you open up the file and it displays in your screen, it looks perfectly united. But as far as the file system is concerned, it's been divided into a couple of different places because it ran out of room. So that's where the next piece of it went. That's a fragmented file. And now what happens? After the disgruntled employee prints out their cover letter, they delete it. And so the space becomes unallocated again. But when you delete the file, it doesn't go away. The space is simply marked as unallocated. It's marked as deleted in the master file table. But until another file comes along and overwrites it, it's still there. So those two fragments are still there. And now what happens is employee creates his resume. And let's say the file system puts it on top of the now unallocated space where the cover letter used to be. And you see what happens is there's still some slack of the original cover letter in light blue, and the second fragment of the cover letter in light blue is still there, but part of it is overwritten by the resume. Now the employee deletes the resume. So that space is regarded as unallocated, but it's still there. And then the happy employee goes to their iTunes account and downloads, I can't get no satisfaction. And let's say the file system happens to put it on top of where the resume used to be. Now let's look at what we've got. Oh wait, let's do another couple things here. Let's delete the customer list. Okay, and maybe I'll do this too. Let's imagine, instead of this being a memory key, let's imagine that this is the hard drive, that the actual hard drive. All the system files are going to be on there too, right? So this is what our scenario looks like now. All the gray stuff is the system files. The green is the active, I can't get no satisfaction MP3. The blue are the fragments of what's left of the deleted cover letter. The orange resume is gone. It's been completely overwritten by the MP3, but the reference to it is still in the master file table. And the customer list is deleted, but fully intact on the hard drive. So, active or forensic e-discovery? Let's look at the difference. If we did active file e-discovery, we'd end up with the two active files, plus whatever system files we might want, which is the MP3 and the PowerPoint. If we did forensic e-discovery, we'd look at the whole damn thing. We'd look at the system files. We'd look at the active files. They're part of it. We'd have access to those fragments of blue, which are no longer a complete document, but might be enough of it left to be interesting, because it's the cover letter. And we'd see that the customer list was there but deleted, but fully recoverable. So how do we do forensic e-discovery? I went through the big target, the circles of active file e-discovery. Forensic e-discovery is a little bit different. Forensic preservation, like we show here, we preserve the whole thing. Every byte, every sector, every cluster, everything is preserved, so all of that is available to us. Make sure you don't boot up the computer or turn it on, because every time you do, certain system files get updated, and you might not want that. Have a forensic expert do it. They use a write blocker to make sure that the process does not write any new data to the disk. Keep it in the same format it was in, using some specialized software. So this preserves everything. You get the master file table, which is very valuable. You get all the active user files, which you want anyway, the system files, caches, the recoverable deleted files, all of the residue of the past disk activity, including the stuff that was deleted. Slack space, unallocated, is all there. One quick point here. When you do it, call it a forensic image. Don't call it a mirror, because mirror is an ambiguous term. Forensic image is a well-defined term. Some people use mirror to mean just the active file copy. So the way to think of it is a forensic image converts the entire storage space to one huge searchable file. So what can you do? I'm going to give you the very quick 3-minute version of what you can do quick and cheap with a forensic image without having to spend a lot of money on analysis. First thing you do, have your forensic expert pull the master file table and give it to you as a spreadsheet. This is very easy. It takes 5 minutes. But imagine you now have, in effect, everything that was in Windows Explorer across the entire hard drive in one searchable, sortable spreadsheet. Incredibly useful, costs almost nothing. What you can do, you can sort by path, and you can see every user account on the system, because all the user accounts are under documents and settings / username, whatever it is, J. Berriman. And then under that, you can see the desktop, every file that's on it. You can see My Documents, every file that's in it. You're not looking at the files themselves, but you're looking at the listings. You can see all of the names of the icons of all the applications that are on the desktop. All right, sort by full path. You can look at the recent folders. The Microsoft operating system does some really weird things that are wonderful from a forensic point of view. One of which is every time you open a file in a registered application like Word or PowerPoint or Excel, it creates a link, and it stores that link in a folder called Recent. And that is the source of the recently used file list that you see when you want to click on, can I see the last 10 files I opened? they never go away. They just accumulate forever. They can accumulate all the way back to the day the operating system was installed. And you can see the name of them in the folders. The files are not necessarily there anymore. They might have been long deleted. They might have been accessed from a memory stick or off the network, but the links are still there. And you can sort through and look at the names of the files that user accessed. Application folder. By sorting through the application folder, you can see the name of every application installed on the computer, and you can often tell the date it was installed because most applications create a folder for themselves when they install, and the create date of that folder is usually that it was the date it was installed. So for instance, if the day before the disgruntled employee left, they installed a registry cleaner or a cleanup utility or a secure file deletion utility, you'll see that. If they installed Dropbox to move data up to the internet, you can see that. Sort by full path, look at the browser cache. The browser cache is where the browser saves a working copy of every website you go to. Webmail can be in there. You can see what sites they went to. I think on the Mucko McDermott case, that was part of how they found the evidence of his false claim of insanity, is that he had done searches for how to fake, yes. So the browser cache can be very valuable. Sort by file extension. This will cluster the listings of all the Word documents, Excel spreadsheets, and see what's on there. Just look at the names. Sort by date. You can see the last files the user touched before they left. Very valuable. These are easy to do because you've got it all as a spreadsheet. Next thing you can do, extract the active user files from that forensic image. The fact that you've done forensic preservation doesn't mean you can't also do traditional active file e-discovery. Have your forensic expert simply pull out all the Word documents, all the Excel spreadsheets, and give them to you to review like any other normal e-discovery. Extract recoverable deleted files. If the file has not been overwritten, like the client list in our scenario, the pink document, that can be pulled out and you, the attorney, can review it just like any other active file. Request a link analysis. I told you that Windows creates these recent links. Your forensic expert can very easily, in just a few minutes, generate a link analysis that shows where each of those pointed, and you can see if they were accessing files on an external hard drive, on the network, on a memory key. Request a USB store analysis. Every time you attach a USB device to a Windows computer, Windows records the date and the serial number of that device, and it never goes away, unless you try to clean it up. And so you can see the history of every USB device attached to that computer. It only takes a few minutes, very valuable. What you'll often see is that the disgruntled employee stuck the memory key in their computer the day before they quit, or the day they quit, or the day after they had the bad review. And that's part of the evidence that shows their intent and what they did. Print spooler analysis. Every time you print a document, a local cache copy is stored by the operating system, so it frees up resources. You don't have to wait for it to print with your arms crossed. They often stay there forever. You can have those cache copies pulled out, and you can see what was printed on that computer, even if the file was never stored on the computer, even if it was printed from a memory key. You can run keyword searches in the unallocated space, so you can find the residue of those deleted documents. And then finally, advanced analysis, and this is on a case-by-case basis. You can search for more sophisticated things. But everything else I talked about, very quick, very cheap, very easy. You can do it in every case, and you, the attorney, can assess the output without the need for a lot of forensic expert analysis. So I hope with all of that, whatever that was, 6 hours worth of law school class in 45 minutes, that was a useful introduction to the division between forensic and active file e-discovery. I should probably end now. I can take a question.
One question.
Does anyone have a question? I'd be glad to. Yes.
What about remoting in? Does that fall under advanced analysis?
You mean, can you remotely preserve?
Can you see from your internal systems if and when an employee remoted in, and if they did, what they did during that session?
Yes. If an employee has remote access to the client's network, when they log in, there are systems, the firewall, the gateways that keep track of the logs, and so you can assess who logged in and when. But was it that person, or was that person someone else using their login? And on, what's the show, CSI? They look for fingerprints on the keyboard, right? We do not do that. But Well, I hope that was all useful. If anyone would like more information, please feel free to call me, and we will make this available.